Good evening to all. Shall I switch off the video? Okay. I think we can start, right? Yes, fine. So today, we are planning to take the fourth module. Out of that, we have to complete two topics there. That is, one is the coordinate measuring machine, and other one is the machine vision. Both these items are used for inspection. Okay, inspection. For what purpose? That is to make the work easier. That is the main aim of this coordinate measuring machine as well as the machine vision. Okay. First of all, let's go through the coordinate measuring machine. It is abbreviated as CMM, coordinate measuring machine. Let's see what are the main benefits on using this CMM. Actually, this is used for checking the dimensions along X, Y, Z axis. That is, three-dimensional measurements can be performed by using what? The CMM. That is a benefit. Okay. And as I told before that it can be mainly used for what? The inspection purposes. Okay. Let's see what are the main items or main parts of this CMM. The first main part is the structure. It holds the X, Y, Z measuring probes. Measuring probes are used there. Okay. Okay. Measuring probes are used there. And what is meant by the probe there? That is just a stylus, just like a pen, which touches the surface of the workpiece. Sometimes it will not touch the surface of the workpiece. Yes? Vishak, any problem? Okay, fine. And next is, so here, the probe may have a direct contact with the surface of the workpiece or may not have a direct contact. Based on that, again, that is again classified. That we will see soon. Okay. Up to this clear to all? What are the main items present over there? Yes, first one is the structure which holds the X, Y, Z measurements probes. And what is a probe? It is the point where it is in contact with the surface of the workpiece. Okay. And then the position sensors, those things are kept on the surface of this probe there. Okay. Next is the control unit. Control unit. See, you might have heard about the computer numerical control machines, CNCs. Yes, good evening, Joel. Yeah, you have already heard about this computer numerical control machines. What is the specialty over there? Yeah, that is the movement along X, Y, Z axis are controlled by means of what? Computer. Just like here also, in the case of CMM also, it is controlled by computer numerical controls. That is what we call as CNC, computer numerical controls. That means everything is done online. Got it? But there exists the manual type is also there. Manual type is also there, where it uses the strength of human being to make this probe touching the surface of the workpiece. Say, suppose this is the probe. This is the workpiece. This probe is moved manually to make it touch on the surface of the workpiece like this. Got it? case of manual type. And here also you have noticed that this is the probe. This is the probe. The probe touches by means of this portion on the surface of the workpiece. Then if it measures, listen carefully, if it measures by means of this probe means, will I get the correct answer? No. Why? Because this much gap is there, right? So that has to be eliminated while giving the result, isn't it? That has to be eliminated while giving the result. That means this radius should be subtracted from the result. For that, certain softwares are there. In the case of manual as well as in the numerical control, so by means of software, that the probe dimensions are eliminated and the proper dimension will be provided. Clear to one? All these things are governed by means of what? The control unit of CMM. So what are the main parts of CMM? What are the main parts of CMM? First one is structure. It carries the X, Y, Z coordinates, isn't it, for measurement. And next is what? The probe. Yes, probe. The probe is used for what? It is the item which holds the sensors. It is the item which holds the sensors, which is in contact with the surface of the workpiece. No, I can't say it is contact. Non-contact type of sensors can also be used. Okay. Next is control unit. Two types are there. Based on control unit, two types are there. Which are they? Based on control unit, the two types are there. Anybody? CNC and other one is manual type, right? Other one is manual type, right? Fine. In the case of CNC, the movements along X, Y, Z axis as well as the display will also be done by means of computer. In the case of manual, X, Y, Z motion is by means of human power, and the display or data, the data evaluation is performed by means of computer. Okay. So these are the things. Okay. So let's go through the note. Up to this clear one? Okay, fine. So all of you can see the note. Yes, fine. Okay. Let me refresh my page. 1 minute, please wait. You hear me? Okay, fine. So here you can see that it is the coordinated measuring machine. First of all, the introduction is written over here. Used to determine the geometric characterization of an object in three-dimensional space, that is X, Y, Z dimensions can be measured. Okay. And then what is the main benefit? The time can be reduced, mainly used for inspection process. Okay. And here you can see that it is programmed to measure the identical parts repeatedly. Okay. And next is what? Basically, the CMM consists of three axes. Say X, Y, Z axes are there. And it can be very easily, we can measure the dimensions easily. So what are the main parts there? That is here it is written, main structure, which consists of three axes there, right? That is, each of these axes can move freely along X, Y, and Z directions. Okay. Next is the probe. It is the main sensor part of the arm. It carries the contact and non-contact sensors. And next is the control unit. I told you that the numerical controls are there and then manually operated are there. In the case of manually operated also, the data evaluation is done by means of the computer. Okay. In the case of CNC machines, okay, the evaluation is conducted and the feedback devices are attached to move that sensors. Okay. Okay, Jessel and Shahul, I think you are late. Be on time on next class onwards. Okay. And next is the types of CMM. Let's see that. Up to this clear to us? Okay, fine. Now we are moving to the next topic, the types of CMM. The types of CMM. Fine. Mainly based on the control. Listen carefully, and you have to give the answer. Based on the control, it is classified into two. Based on the control, it is classified into two. Which are they? Yeah, manual and CNC. So that is the first type. The first classification over. Okay. Next is, the second is based on the structure that we are going to discuss. Based on the structure we are going to classify. The first type is the bridge type. The bridge type. Bridge type CMM. Okay. So from the name itself it is clear that it forms a bridge. Under that bridge we are placing that workpiece over there. Like that way you are going to measure. Okay. Let's see how I am going to draw. Why I draw here? Because so that very easily you can draw like that at the time of examination. Okay. The native notes will also be given there. So here you can use this bridge itself to draw it on the paper also. There exists a strong base for holding all these items. And there exists a rail for the movement of x-axis, movement of the item through x-axis. Okay. Here it is a vertical pillar for holding the bridge. And this is the horizontal member which forms the bridge over here. And this bridge carries the probe that you know where the sensors are kept over there. Like this. And here is the horizontal member that is called as the bridge. Here is the vertical member that is called as the post. Okay. And by means of this item, this can move like this, these positions. That is, this entire unit can move along through the guide wires placed on the base. Hope you all have seen the lathe, right? Lathe machine tool. Yeah. You can see there the guide wires like this. The flat and V guide wires are there, right? For what purpose? For the movement of the carriage as well as for the movement of the tailstock, right? The guide wires are there. So just like here also, there exists certain guide wires for the vertical post to move over there. When the vertical post is moving, the entire unit, that is this bridge as well as this vertical post, is moving through this platform like this. So that is x-axis. Okay. And next is, what about the remaining two axes? Yeah. The Y motion can be obtained by means of the movement of the probe like this through the guide wires on the surface of this bridge. Through the guide wires on the surface of the bridge. Okay. And next is, that is our Y motion. Y motion. Okay. Next is the Z motion. This probe can move up and down. This probe can move up and down. That is Z motion. This is how all these motions can be entertained by means of the bridge type CMM. Bridge type CMM. Then, what shall be the main drawback? You might have seen in the roads, you can see that certain bars are placed to obstruct the heavy vehicles, right? Yes, just similar that this bridge is an obstruction, isn't it? This bridge is an obstruction for what? The heavier work pieces to engage, isn't it? So that is the main drawback of this bridge CMM. Yes. Clear one? Okay, let's see the note. The type of CMM? Yes. That is the manual CMM and CNC CMM. That is the first case that we explained above. Okay. Next is bridge type CMM. Yeah. You can see that figure here. You can see that there exists a strong base is there. And next is what? Here, this is the point through which it can move along x-axis, isn't it? X-axis. The gateways are placed over here like this. And here, this one is the bridge. Okay. And this one is what? This one is the post over there. And then it can move up and down. This can be moved up and down. That is what? The Z motion. And next is, this can be moved in this direction also. That is, the Y motion is also obtained. Is it clear to all? Okay, fine. Now we are moving to the next type of CMM. That is the cantilever type CMM. Cantilever type CMM. From the name itself, it is easy for you to understand because it looks like a cantilever, the sunshade of your house. Just like that it will appear. Okay. For that, there exists a base. For that, there exists a base. Just similar to the previous mission. And this portion, there exists a vertical member like this. Okay. And then it is on this vertical member the probes are going to be placed. Instead of bridge, a cantilever is placed over here like this. Okay, a cantilever is placed. And at the end of this cantilever, yes, that probe is to be placed like this. This probe can move in this direction like this. Okay, that is what? That is the Y motion. And next is, this can be moved up and down like this. That is Z motion. What about the X? Yes, X motion is done by means of this vertical member, like this. See, on this vertical member, this cantilever is moving. That is X motion. What is the benefit of cantilever over bridge? What is the benefit of cantilever type CMM over bridge type? Can you guess? What is the benefit of using the cantilever type CMM over bridge type? See, one side of this cantilever, yeah, no restriction is there, no obstruction is there, right? That is, one side of this CMM is free for the larger workpieces to enter, right? That is the benefit of using cantilever type when compared to the bridge type. Is this clear to all? Yeah, fine. Let's see the note. Yes. So here you can see that there exists a vertical member is there and the base is there, and then it is on that vertical member we can see that horizontal member over there. It is on that horizontal member that probe can move along x-axis and z-axis. Both these motions can be performed. And this horizontal member moves on this vertical column like this. Okay, that is X motion is also achieved. All these things in words it is written in this note. Just go through that when I send it. Up to this clear to all? Yes, fine. Now moving to the next type of CMM. That is, next type is what we call as the column type CMM. Have you seen milling machine or drilling machine? Yes. What are the main parts you have seen there? Yeah, it consists of a base, isn't it? It consists of a base. 1 minute. Yeah. It consists of a base is there, and then yeah, arbor is there, and then where the arbor is placed, the arbor is placed on a column there, right? Arbor is placed on a column there, isn't it? The vertical member. Yes. So these are the parts. So here also these things are there. That is, this represents the column, and I am going to represent the horizontal member that you call that as arbor. Okay. That horizontal member is also here. Okay. So everything is ready. Here, in this case, the probe is attached on this arm like this. Here, this is the base. This is the column. And here, this is the arm. And on the arm, the probe is placed. The probe can move only in either direction. That is up and down motion. Up and down motion is only there for the axis. Then what about the X and Y motion? Yes, for that there exists a table there. Okay, for that there exists a table there on the surface of the bed like this. This table can move along x-axis as well as z-axis, just like that you have seen in your milling machine. In the milling machine also you can see that, isn't it? This table can move along x-axis and along through the y-axis also. Got it? So the workpiece is kept over here like this. And this, by means of this table, it is moved along x-axis and the y-axis, and then the z-axis movement is governed by means of the probe which is kept on the column. Is it clear to all? The column type? Okay. So, you can notice the difference also. In the case of column type and the cantilever type, yes, you can see that the probe is kept on a cantilever. The difference is that in the case of cantilever, X, Y, Z motions can be provided by means of that horizontal arm itself. But in the case of column type, the horizontal arm can provide only what motion? The Z motion. The remaining motions are governed by means of whom? Tables here. That is the main difference. Clear to all? Okay. Now let's see the note. The column type you can see here. Yes, this is the base. This is the base. And then here is the column. And at the end of the column, you can see that the probe is attached. This probe can move only up and down motion. That is, Z-axis motion is there. Z-axis motion is there. And then, what about the other two motions? The other two motions are done by means of the table. X like this and Y like this. Okay. Now we are moving to the next type of a CMM. That is gantry type. Gantry type CMM. Okay, let's see that. So in this, we can call this gantry type of CMM as a rigid CMM, which is used for measuring certain heavier workpieces like lathe bed, machine tool beds, etc. can be checked by means of this gantry type. Not only that, it can be used for checking the car body, then wind tunnel, those things we can use. Have you seen the automatic car wash machine? Fully automatic car wash? Yes. You can see that one at the end, at the last time, you can see that one item is coming near to your car to drain out the water from that body. Have you seen that? Yes, that is just touching the surface of the body, isn't it? Yes, that such type of machine is what we call as a gantry type. Got it? Okay. Now, you got an idea. So, let's see the figure here. So, that means here there exists nearly 4 or 5 legs are there for this machine. 4 or 5 legs are there. So, here I am drawing here only 3 legs. Okay. And next is a rail is there on the top like this. Like this. And on that surface, there exists a horizontal member. And this horizontal member carries the probe like this. This probe can move in this direction through this surface like this. By means of gateways, through this horizontal arm, it can move in this direction. That is, which axis? That is the Y motion can be entertained. Next is, the up and down motion can be done by means of, through this horizontal arm itself. This probe can move up and down. that is Z motion can be entertained. Next is the X motion can be done by means of this structure, X axis motion. It is similar to the bridge type, but the construction is somewhat heavier. And it can hold the larger equipment also. Even a truck can also be placed under this one. Okay. Is it clear to us, the gantry type? So sometimes the question will be asked at an application level. Which type of CMM is used for inspecting car body, wind tunnels, etc.? Explain in detail. So you have to write this gantry type. Clear to all? Okay, let's see the note. Here you can see the figure. Here 3 pillars are here. 3 pillars are here like this. And here you can see the probe. And this, by means of this, you can move up and down. Up and down motion can be done. That is Z motion. Next is X motion is through the surface like this. Then Y motion, where by through this horizontal arm it can perform. Okay. All these things it is written in the form of wordings. Here you please go through this one. Okay. Next is the horizontal type CMM. Horizontal type CMM. So the thing is that it is similar to the cantilever type. Only the thing is that the based on the motion, that is the cantilever type consists of a base is there, and then it consists of what? In the case of cantilever type, it consists of a base and a horizontal member, right? Which is kept as a cantilever. Here is the base, and then there exists a vertical member like this, and from here there exists what? A horizontal member is also here, right? This is the base, and this entire unit is what we call as the base. And it is on here, the vertical member is placed, which is placed on a guideway. Okay. And this can move in which direction? X direction. X direction is entertained. Then next is, in the case of horizontal type CMM, the difference is the up and down motion is through this column. That is, it is placed here like this. like this. It is kept. Okay. And this can be moved up and down. That is, Z motion is done by means of this horizontal member on this vertical member. This is the horizontal member. This is the horizontal member and this is the vertical member. The Z motion is entertained with the help of this horizontal member on this vertical member. Next is how that Y motion is then entertained. Yes, that is done by means of a probe by moving along this plane. So this is a probe. This can be moved through this plane. So no motion is there for this probe there. Sorry, no Z motion is there for the probe there. Got it? That is the difference. And in this case, you can see that the probe is moving along y-axis, right? The probe is moving along the y-axis. Instead of moving that probe along y-axis, is it clear to all? In this case, the probe is moving along y-axis. Instead of moving this probe along y-axis, the probe is kept stationary on this horizontal member. Instead of that, the table is going to move along the y-axis. Based on that, it is classified into two. This horizontal type CMM is classified into two. The first one is the moving arm horizontal type CMM, and that is the first one I told you. That is, this probe can move through this horizontal arm. Next is moving table CMM, moving table horizontal type CMM. In that case, this is held stationary. The probe is held stationary. This table is moving there. That is the difference. Is that clear to all? Okay. Now let's see the note. You can see here, the first one is the moving arm horizontal CMM. Okay. Here you can see that this is the base. And over that base there exists the gateways. And then over the gateways there exists the column. This entire unit can move on this base like this. That is X motion. This probe can, this is this horizontal member. This horizontal member can move up and down. That is Z motion through this column. Then what about the probe movement? That is Y motion. Y motion is done by means of the probe through this horizontal arm. So in this case, the arm is moving. Next is the table. In this case, the arm is held stationary. The probe will not move. It is held stationary over here. Then what is moving? This table is moving there. That is the difference. So that is moving table horizontal type CMM. Up to this clear to all? Okay, fine. So far we discussed the types of CMM, right? The types of CMM. What are the types we discussed? Based on the control, it is classified into manual and CNC. Next is based on what? Based on the based on the structure, it is classified into. First one is what? Yes. First one is cantilever type. Yes. Bridge type. Then column type. Then gantry. Next is horizontal arm. Okay. So these are the types. Is this clear to all of you? Okay, fine. Now we are going to discuss about the types of probes. Types of probes. Okay. What is probe? The probe is a member of a CMM which holds what? The sensors, right? To determine the position. That is what we call as a probe. Okay. And then, I told you that at the time of explanation of this probe, there exist mainly two types are there, of sensors are there. The first type is the contact type. The contact type. And the second one is non-contact type. Okay. Next is, first of all, we can discuss about the contact type of sensors, probes. Okay. So, first type is what we call as fixed probe. Fixed probe. Here, in the case of fixed probe, the main drawback is that it uses the manual manipulation. That means what? You have to move along X, Y and Z axis to make it touch with the surface of the workpiece. That is the main drawback. Okay. And the data analysis is carried out by means of a computer. That means the display will give you the correct solution, eliminating the diameter of the probe. That means suppose it is using a spherical probe. The problem is what? It will touch the surface of a workpiece like here. And I got the indication of this one. This coordinate will be indicated on the recording device. The problem is what? This much length is what the diameter, the radius of that probe. So that you have to reduce. So that will be automatically reduced with the help of what? The software. Clear? So that is called as a fixed probe. The fixed probe, it uses the manual manipulation, and another one is what? The readings are generated with the help of what? A software. Next is the touch type. The touch type probe. Nowadays also it is commonly using the touch type probe because accuracy is much more higher when compared to other CMMs. Okay, the touch type probe, or sometimes we call that as trigger touch probe. Okay, trigger touch type probe. Here it uses a probe like this, which is held by means of three bearings. We call that as 3-point bearing. We call that as 3-point bearing. So that this is free to move like this. Not only like this, in all the 6 degrees of freedom, it is free to move. Got it? What are the 6 degrees of freedom? The X, Y, Z. Negative X, negative Y, negative Z. Total of 6 degrees of freedom. All these degrees of freedom can be done by means of this probe. Why? Because it is governed by means of a item called as 3-point bearing. It is held on a circular surface. So this is the probe. The end of the probe, which is spherical in shape, that is called as stylus. Here it is spherical stylus. Okay. And once it gets touches with the surface of the workpiece like this, what will happen? It will slightly bend off. It will slightly bend off. Okay. And when it is released, it will regain its original shape by means of a spring attached to this probe. By means of a spring attached to this probe. So this is the ended unit of the touch type switch. We call that as touch type switch. Instead of a touch type switch, we call that as trigger switch. Okay. And here is a spring to regain the original shape. Up to this clear to all? Yes. Once again I shall explain. Here the main item is what? The probe. There exists a spherical member called a spherical stylus, and it is held by means of what? And it is held by means of 3-point bearing. 3-point bearing. Which ensures what? Which ensures what? 6 degrees of freedom. That means this probe can move x, y, z, minus x, minus y, minus z directions. Okay. Then, once it touches the surface of the workpiece, when it is released, it will regain the original shape with the help of a spring there. The ended unit is what we call as the trigger switch. And then, how we can measure the variation or how we can measure the dimensions of the workpiece. Yes. When it will tilt off, yes, it will make certain movements on the electrical circuits present over here. This 3-point bearing is connected to an electronic circuit. This electronic circuit will produce certain signals. That signal is converted into the position, and hence the displacement can be measured. Is it clear to all? Okay. What about this? Is it clear to all of you? Yes, okay. So here there exist electronic circuits also. So these are the main components present inside this one. Let's see the note. First of all, the fixed probe. Yes, here you can see that it requires manual manipulation. Then readings are generated is adjusted to compensate the diameter of the probe tip. Then I told you about the tip. What is another name of the tip? What is another name of the tip? Just now I told you. Stylus. Right? The stylus. Yeah. The different shape of stylus we can use. You can see here. Conical. It is used for locating hole. Ball type. It is used for surface location. Cylindrical. For slots and holes we can use. Next is touch type. You can see here. This is the 3-point bearing. You can see here. That is placed on a electrical circuit. And next is here is the probe. The end is what we call the spherical stylus. Next is a spring is also there. For what? For the regaining the original shape. And here is the workpiece. Once it gets interrupted, what will happen? Yeah, the electrical signals are generated. That will be calibrated to give the position. Clear to all? Yes, fine. Now we are going to discuss the next one, that is next contact type is called as displacement. Displacement probe. Displacement probe. Yeah, okay, non-contact. Before going to the non-contact, we have to discuss one more type of contact also. That is displacement probe. So how many contact types we discussed? The first one is the fixed probe. The second one is the touch type, right? The touch type. And the third one is displacement probe. Three Three types are there coming under the contact type. The displacement probe is very much familiar to you, that is named as LVDT. You might have heard this in electronics, right? Linear Variable Differential Transformer. Okay. You will learn in detail in the fifth module about the transducer. It is a transducer. Then why it is named as a transformer there? What is the meaning of transducer? Both the transducer as well as the transformer converts one form of energy to another form of energy. That is what we call as transformer. The transducer also doing the same thing. It is also converting one form of energy to another form. So we can call the transducer as the transformer itself. So here also, in the case of linear variable differential transducer, you are going to convert the voltage variation to displacement. Okay, how it is going to vary? You all know the Faraday's principle. That is, a coil is there and a moving arm is there. When this moving arm, that is what we call as a core, isn't it? When this core is moving inside this one, it will cut the magnetic flux if it is connected to the EMF, right? And then electrical impulses are produced from here. What will happen when this core moves to this much distance? Yeah, correspondingly the EMF will be generated. When it is moving to this much distance, yeah, again that EMF will be generated up to this position. That means their intensity will be high. Based on that EMF generated, we can calibrate what? The displacement traveled. By means of this principle, we are going to measure the displacement by using the displacement probe. LVDT is attached along X, Y, Z axis. When it is in contact with the surface of the workpiece, this core is moving inward and displacement is measured. Got it? When it is in contact with the Z axis, yes, the probe again along the Z axis is moved and it is measured. Similarly on the Y axis. This is how the displacement probe works with the help of LVDT. Is it clear to all? Okay. Now we can jump to the non-contact type of sensors. Sorry, non-contact type of probes. Non-contact type. The first type of non-contact is what we call as optical probe. This is mainly used for inspecting PCB. What is that? That is called as printed circuit boards. In air conditioners, in the even in our LED light also there exists a PCB. Printed circuit board is there. You might have seen certain green colored, golden colored lines are there on this board where we are placing the electronic components. Have you seen that? Simply the board, electronic board. Okay. Yeah, that is what we call as a printed circuit board. So, whether that part drawn on this one is correct or not, that can be inspected with the help of this optical probe machine. Got it? With the help of this optical probe. Optical probe worked with the help of a projection microscope. Hope all of you have a Metrology and Instrumentation lab this semester, right? Yes. Okay. In that you have noticed one microscope there as tool maker's microscope, right? Yes, fine. In that tool maker's microscope, you are viewing that tool through an eyepiece, and near the objective, you are placing that tool over there, and the shadow of that tool you have seen through the eyepiece there. Same way, this projection microscope works. the shadow of that item is generated on the eyepiece, and I can measure those lines or drawings over there with the help of various measuring devices on that microscope itself. See, in the toolmaker's microscope itself, you can measure angles, linear motions, etc. Am I right? In your lab, you have noticed that in the toolmaker's microscope, you can measure angles as well as linear motion. Those things can be measured. Yeah, same way here also, we can measure all those things. And it is mainly used for inspecting the printed circuit boards, certain drawings, mission drawings, those things you can inspect with the help of what? The optical probe. Is it clear to all of you? Okay, fine. Next is acoustic. Acoustic probe. What is the meaning of that? What is the meaning of acoustic? Sound. That is the acoustic, meaning of acoustic. By means of the sound, by means of the sound, when the probe touches the surface of the workpiece, that is going to be measured. Got it? And another good example is, you know the crack, the brittle as well as the ductile fracture. In the case of ductile fracture, as you already learned, the lot of internal cracks will be developed. Isn't it? When you're giving a stress over there, lot of internal cracks will be developed, but you can't see it on the outside surface, right? But I want to check that. How? By means of this acoustic probe, we can check this. Got it? That is, when it is going, when a crack is developed inside this one, what will develop? The sound will develop, right? By noticing or by inspecting that sound which is developed here, we can check how much crack is developed inside. So that is done by means of what? Acoustic probe. Is it clear to all? Yes, fine. Next is laser probe. Fine. Laser probe. From the name itself it is clear. That is, the laser light is used to check the dimensions of the surface of the workpiece. How? By means of the reflected image. By means of a triangulation method, isn't it? That is, but the light is reflecting from the surface of the workpiece, and based on the time of reflection of that light back to the collector, yes, that is measured. That is with the help of the laser probe. Next is vision probe. Vision probe. That is with the help of the camera itself. You have to take the image and then it is processed, and then it is interpreted. That is the next topic, which topic we are going to learn, that is called as machine vision. Up to this clear to all? Okay. So here you can see that the displacement probe and non-contact type optical probe is here. It is used for checking the printed boards. Projection microscope is used. And next is acoustic. Yeah, it uses the sound waves generated to check this one. And next is laser probe. It uses the laser light. Vision means, by using the camera, the picture is taken and it is digitized. It is digitized means it is converted into dimensions, of the workpiece. Now we are going to learn the last topic, that is the machine vision. Machine vision. Okay. So the main components of machine vision includes one camera for taking the pictures. So images are grasped by means of this camera. We call that as an image sensing device. Okay, because there exists a lens is there to collimate, and as well as the light source are there. All these units are incorporated under image sensing device. Okay, and next is the image analysis. Image analysis. That means it is segmented. That means unwanted portions will also be captured. See, I want to check the workpiece. Along with this, I got the table also, right? So those tables will be removed. That is what we call the segmentation. And next is, among that, I want to check only the length and the breadth. That means the remaining all other portions are eliminated. That is what we call the image analysis. The segmentation is carried out. Okay. Then I told you about I want to check the dimension of the hole. I want to check the dimension of the hole only. So these portions are also be eliminated. This feature is extracted. So segmentation, feature extraction is done. Segmentation, feature extraction, etc. Those things are performed by means of image analysis. So I got the proper information. Okay. And then next is what? Interpretation. It is done by means of what? A CPU. It is comparing those items with a already stored standard. A standard picture will be there. It is comparing with that standard. Say, for example, 8 mm diameter hole is there. After feature extraction, I got only 7.5 millimeter diameter hole is there. So it will show, by means of a display device, it will show an error of 0.5 will be displayed. That is, everything is evaluated with the help of what? The pictures, by means of images. Clear to all? This is what we call as the machine vision. What are the main steps? First one is what? Image sensing. Second one is image analysis. The last one is interpretation. Okay, these are the 3 steps. And then, let me take the note to explain that. See, these are the things. Image sensing, image analysis, and image interpretation. Okay. Then, here you can see one figure. Here is the workpiece. The workpiece is kept over a material handling device. A pallet is here. It is moving here like this. Here the light source is there, and then a lens by means of a sensor. That means the sensor locates the workpiece in position. After that only, the light as well as the camera is switched on. Okay. When this workpiece is in position, this camera and light get switched on. The camera takes the picture. The image is processed. And next is image is interpreted. That means what? Image interpretation means, it is checking it with the non-standard. Then it is displayed in a display device. Sometimes it will activate the actuator also. Actuator means what? It's a motor. Here, it is giving signal to the actuator. That means actuator is the material handling device. That means it wants next workpiece here. Okay. So this pallet will move over here. Next workpiece, which is kept over here like this, will come and entertain to this point. Got it? That is, after inspecting this one, this will be moved to this position. So that information also be governed by means of what? This image interpreter itself. Clear to all? Okay. So this is what we call the machine vision. So now we completed 90% of the fourth module. From 10%, that is only two more topics are there. One is the alignment and alignment inspection, and another one is laser interferometry. Interferometry we already discussed, but once again I shall give you. So these two topics are there. Okay. So my plan is to give one assignment which consists of questions from third module and fourth module. Okay. And so that questions will be given through the Google form today itself. By 9 o'clock I will give you. You have to submit those things on or before 30th of March. And on 31st, you will have the next class. Okay. And next, we will discuss the remaining topics of this fourth module, and also we will start the fifth module. The fifth module comprises of certain topics like calibration, accuracy, sensitivity. Those things are there. Those things we already discussed along with the first module. Hope you can recollect. Okay. So I skipped those portions which already I taught you along with the first module, and the remaining topics will be entertained. So please cooperate with me. Please do the task and complete the task before 30th itself. Okay. Okay, Harris, I will give you certain considerations to you. Okay then. I think we can stop for today. Is this topic clear to all of you? How to submit the work? Yeah. See, you have to write it by using pen and paper. Take the photograph, convert it into PDF. That is by using the CAM scanner. You can scan it and then convert it into PDF and upload it through that link. Few objective questions will also be there along with that. Yeah, that I will send to you. Today evening I will send to you. Okay, Jay. Okay. Is the topic clear to all of you? These topics which we discussed today? Are you happy with this class? Yes, fine. Okay then. Bye all. Take care. Yes, over again.